Okay, so let's get into the first part, which is the introduction. But before that, let me introduce myself. My name is Shairul Haziq bin Shafrizal. Matrix number DD210055. So for the introduction, Pelton turbine is the type of impulse turbine which is used to convert the pressure energy of water into the kinetic energy, due to which the wheel moves and produces electricity. The purpose of this lab is to measure the output of a Pelton wheel turbine. The Pelton wheel turbine in this experiment is used by the H19 model. H19 model is used because of the transparent front panel that can make the student can view it from the outside. So next is variable mechanical load is applied using a straightforward mechanical brake and spring balance assembly linked to the Pelton wheel shaft. Student can use this along with the speed to determine how much the turbine is absorbing. Inlet pressure is measured by a gauge. So next is the objective. There are three objectives that we need to achieve in this experiment. First objective is to measure the flow rate of the water. Second objective is to measure the speed of the turbine. And third and last is to determine the power absorbed by the turbine. Okay, so let's continue to the next part, which is the result. So for the result, we have two parts, which is the first part is half open valve and the second part is fully open valve. So for the first part, which is the half open valve, we set load F1 to 0, 50, 100 and 150, and then we get load F2 0, 62.5, 87.5 and 112.5. So we calculate the speed for each load, and then we get the RPM for each load, which is 2620, and second is 1832, third is 1141, and last one is 882.3. So to convert the RPM to radian per second, we have to calculate by using the formula V times 2 pi over 60, and then we get first load is 274.36 radian per second, second is 191.85 radian per second, third is 119.48 radian per second, and last one is 92.39 radian per second. So for the next is inlet pressure. The inlet pressure we obtained from the Pelton turbine from the pressure gauge. So for the first load is 1 MPa, second is 1.05 MPa, third is 0.95 MPa, and the last one is 0.9 MPa. So for the next is the time to reach 5 liter. So for first load, we get 23.94 seconds for it to complete 5 liter, and next is 24.95 second, and third is 25.06 second, and the last one is 24.37 second. So for the next part, it is the torque. So to calculate torque, we have 2 pi times 0.5 the power, and then divided by 60 times speed. So from that we derive, and then we get the equation of 9548 times 0.5 divided by the speed. So for the torque, we get 2.73 for first load, second load we get 3.91, third load we get 6.28 Newton meter, and the last one is 8.12 Newton meter. So next is power in. So to calculate power in, the formula for power in is torque times the angular velocity, which is the radian per second. So for first load we get 749 watts, and second load we get 750.13 watts, third load we get 750.33 watts, and the last load we get 750.21 watts. So to the next calculation is the flow rate, which is the formula given for the flow rate is V over T. So the flow rate for first load is 12.53 liter per minute, and next load is 12.02 liter per minute. Third load is 11.97 liter per minute, and the last load is 12.31 liter per minute. So for the power out, the formula is Q times P times 10, which is the inlet pressure, times 10, and then divided by 0.6. So after we calculate, we get power out for first load 208.83 watts. Next, second load is 210.35 watts. Third load we get 189.53 watts, and the last load we get 148.65 watts. So the last calculation, we have the efficiency, which is the formula is power out over the power in. So first load we get 0.2788, second load we get 0.2804, third load we get 0.2526, and the last load we get 0.2461. For the next part of the result, which is part 2, the fully open valve. So all the calculations and formula are the same as the part 1. So for load we set 0, 50, 100 and 150 newtons. So F2 we get 25 newton, 50 newton, 75 newton and 100 newton. So for speed we get 2885 RPM for first load. Second load we get 2658 RPM. Third load we get 2536 RPM, and the last load we get 2324 RPM. So for radian per second, we get first load 302.12 radian per second. Next is 278.35 radian per second. Third is 265.57 radian per second, and last load is 243.37 radian per second. So for the inlet pressure, for first load the inlet pressure is 0.9, second 0.9, third 0.9, and the last one is also 0.9 MPa. So for the time to reach 5 liter, first load we get 12.86 second, second we get 13.18 second, third we get 13.48 second, and the last one we get 13.65 second. So for torque, for the first load we get 2.48 Newton meter, second load we get 2.69 Newton meter, third load we get 2.82 Newton meter, and last load we get 3.08 Newton meter. So for the power in, first load we get 749.26 watts, second load we get 748.76 watts, third load we get 748.91 watts, and the last is 749.57 watts. So for power out for the first load we get 349.95 watts, second load we get 341.40 watts, third load we get 333.9 watts, and the last load we get 329.7 watts. So for the flow rate, the first load is 223.33 liter per minute, second load is 22.76 liter per minute, third we get 32.26 liter per minute, and the last flow rate is 21.98 liter per minute. So for the efficiency for the first load we get 0.336, second we get 0.4560, third we get 0.4452, and the last one we get 0.4399.
So my name is Nicholas Bowing. So this is the observation part. For the experiment, there are two parts, which is part 1, half open valve, and part 2, fully open valve. So the first one is the load F1 on the turbine increased from 0 to 150 Newton. The rotational speed of the turbine decreased from 2885 to 2324 RPM in the part 2, and from 2720 to 882.3 RPM in part 1. 2. As the load F2 on the turbine increased from 25 Newton to 100 Newton in part 2, and from 0 Newton until 112.5 Newton in part 1, the time to reach 5 liters decreased from 12.86 seconds to 13.65 seconds in part 2, and it increased from 23.94 seconds to 24.37 seconds in part 1. 3. The inlet pressure data for part 2 were constant at 0.9 megapascal for all loads, while in part 1, the inlet pressure was varied from 1.0 megapascal to 0.9 megapascal. This could have an effect on the overall performance of the turbine, as the inlet pressure is one of the key parameters that affects the turbine performance. A higher inlet pressure leads to higher water velocity and thus more kinetic energy, which is converted to mechanical energy. And uh, and that could be the reason for the deviation in the rotational speed and time to reach 5 liters.
Assalamualaikum warahmatullahi wabarakatuh. My name is Putri Syajaratunansyah. So today I'll present about the list of equipment that we use in this experiment and the procedure that we do in this experiment. In this experiment, we used 8 equipment. First, which is nozzle. A nozzle is a device designed to control the direction or characteristics of a fluid flow, especially to increase velocity as it exits or enters an enclosed chamber or pipe. Second one is the bend brake. A bend brake is a primary or secondary brake consisting of a band of friction material that tightens concentrically around a cylinder pieces of equipment, or MUs, to either prevent it from rotating a static or holding a brake, or to slow it a dynamic brake. Third is the Pelton wheel. The Pelton wheel extracts energy from the impulse of moving water as opposed to water's dead weight like the traditional ovation. Fourth is the gate valve, which is opened by lifting a barricade out of the path of the fluid. Gate valve require very little space along the pipe exit and hardly receive the flow of fluid when the gate is fully open. The fifth one is the needle valve. A needle valve is a type of valve with a small port and a threaded needle-shaped plunger. It's always precise regulation of flow, although it is generally only capable of relative low flow rates. And the sixth one is the pressure gauge. Pressure gauge instrument for measuring the condition of a fluid, which is liquid or gas, that is specified by the force that the fluid would exert when at rest on a unit area such as pound per square. Next is the tachometer. The tachometer is the instrument measuring the rotation speed of a shaft or disc as in a motor or other machine. The device usually displays the revolution per minute on a calibrated analog dial, but digital displays are increasingly common. The last one is the stopwatch. Stopwatch is a timepiece designed to measure the amount of time that elapsed between its activation and deactivation. A large digital version of stopwatch designed for viewing at a distance. There are 7 procedures that we do in this experiment, which is first we're going to start the centrifugal pump, which supplies water to the turbine. Next, we will adjust the spill valve and main valve in order to maintain the pressure head. And during the course of the experiment, the head of the turbine is to be maintained constant. Next, we will note down the pressure gauge reading. While after that, we will load the dynamometer by adding maximum possible weight at the end of the rope, which caused speed to fall. After that, the experiment repeated at different loads at equally spaced interval between maximum to minimum load. And last one, at every load, we measure the runner's speed and the flow rate.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Arifidos bin Muhammad Yusuf, CD210240. So, for our experiment, we have divided it into two parts. Part 1 is half open valve and the second one is fully open valve. So, from this result, both experiments have the same load and both F2 show increasing result while we add more load at F1. This shows that when F1 is increased, F2 will also increase. So both experiments show decreasing movement when we add more load. This is the best result that we need to get because as the load increases, the speed will decrease. The inlet pressure for this experiment didn't turn out as we want because our pressure gauge is broken. During our first experiment, it is showing decreasing movement, but during the second experiment, it turned out that the pressure stayed the same. This shouldn't be the data that come out because we think the pressure should increase because more loads had been put into the water. So there must be a lot more of pressure to move out from the tube. During calculation, the torque has shown increasing trend, which is the right conclusion as the load is also increasing. The power in and the power out is based on the motor that we have broken and worked properly. Overall, the data result has shown a logic result even though the pressure gauge didn't work properly as it's supposed to do. So that's all from me. Thank you.
Hey to everyone, my name is Pranitha Analagi Subramani. My metric number is CD210041. Now I'm going to talk about conclusion. The experiment was not fully accurate due to several errors that resulted from several misdoing. It became really difficult to acquire readings from the spring balance since the setup was vibrating as a result of the operation of the machine. As such, this explains the slight deviation of the result obtained in the experiment. Others may have resulted from unseen leakages in the system and observational. The experiment was, however, carried out with a great level of keenness to reduce the occurrence of such errors. Next, for the recommendation of one is DC motor can be coupled with the shaft to generate electricity, but this power will be very small. Recommendation 2, bucket material may be changed. Different materials such as stainless steel, carbon steel composite, or methylene can be used to which may improve the efficiency of the Pelton turbine. Recommendation 3, the disposal water can be recycled. Thank you.